In a universe where mysteries abound, the James Webb Space Telescope has unveiled a cosmic conundrum that defies our understanding of time and space itself. Could galaxies older than the universe as we know it truly exist? Stay tuned as we dive into this astronomical enigma that's rewriting the rules of the cosmos. Each colossal entity once existed in its infancy, a stage often hidden from our view. NASA's cutting-edge space telescope is now illuminating the early chapters of the universe's history, previously beyond our grasp until June 2022. The James Webb Space Telescope, upon capturing its initial deep-field image, unearthed a multitude of distant galaxies. Suddenly, galaxies emerged from the obscurity of time and space, presenting themselves in a manner that defied our prior understanding. This marked the universe's divergence from what we had long considered its dark ages, casting doubt upon the established principles of our cosmic model. The Webb telescope didn't merely spot a handful of galaxies, it unveiled hundreds. Among these, an Austin-based astronomer named Stephen Feldstein stumbled upon one, which he christened Maisie's Galaxy in honor of his daughter, as it was discovered on her birthday. Initially, the scientific team believed this galaxy had formed shortly after the Big Bang, estimating its age at a mere 290 million years post-Big Bang. However, advanced equipment analysis later revealed it to be approximately 100 million years older. Nevertheless, this discovery still retained its distinction as the oldest galaxy ever observed, emerging a mere 390 million years after the Big Bang. Nonetheless, the title of the universe's oldest observed galaxy might soon change hands. Presently, the Southeast team is scrutinizing around 10 additional galaxies that could potentially surpass Maisie's Galaxy in age. According to Fabio Pacucci of the Harvard-Smithsonian Center for Astrophysics, we're witnessing the emergence of massive galaxies at a pace swifter than previously conceived. Some of these early galaxies are thought to have existed for a mere few tens of millions of years. This revelation could carry implications for the formation of early galaxies and their relationship with massive structures of dark matter referred to as halos, as per our current understanding of cosmology. Indeed, some perplexing and potentially paradigm-shifting early universe candidate galaxies remain, with the leading contenders being a class of galaxies unearthed by researchers at Australia's Swinburne University of Technology. This team came across galaxies boasting billions of solar masses, akin in weight to our Milky Way, originating from a mere estimated 750 million years following the Big Bang. These galaxies are between 10 to 100 times more massive than the galaxies previously observed from this era, and are densely packed within structures 30 times smaller than our Milky Way. What adds to the intrigue is that these galaxies appear to be accommodating a significantly larger number of stars than we had anticipated. This development has fundamentally challenged the bedrock of our comprehension regarding the formation of massive structures throughout cosmic evolution. It brings to mind the sentiments expressed by Michio Kaku last year when these early galaxies first surfaced in the Webb telescope's images. He remarked, "Well, that's the problem. The James Webb Space Telescope is causing a major upheaval. Suddenly, we find ourselves confronting the possibility of having to rewrite the textbooks on the origins of the universe." To put it into perspective, crafting a galaxy like the Milky Way, with its 100 billion stars and its age spanning billions of years, typically takes an enormous amount of time. However, the James Webb Telescope has detected 6 galaxies that came into existence only 500 million years after the Big Bang, and astonishingly, they are up to 10 times larger than our Milky Way galaxy. This defies conventional expectations, as primordial galaxies of such magnitude should not exist, especially at such a young age. This anomaly suggests that our current theory about the formation of the universe may need to be reevaluated, as indicated by observations made last year. Furthermore, the exploration didn't conclude with these revelations. More recently, the Webb telescope identified galaxies resembling the Milky Way at the farthest reaches of the universe, which, according to the principles of our physics, should not be possible. Many of the early galaxies, similar to those observed by the JWST, were teeming with luminous gas, so brilliant that the gas itself could outshine newly emerging stars. These recent discoveries shed light on just how prevalent these radiant, youthful, gas-rich galaxies were when the universe, at a tender age of 2 billion years within its 13.8 billion-year existence. Recent observations have unveiled that nearly 90% of these galaxies displayed what astronomers refer to as extreme emission features, signifying their abundant luminous gas content. Furthermore, as scientists delved into the study of these early galaxies, they happened upon an astonishing revelation: the most remote galaxy in the universe, resembling our very own Milky Way. Yes, you heard that correctly. When the universe was merely 2 billion years old, a newly discovered spiral galaxy named Sears 2112 exhibited a central bar composed of stars and gas slicing through its core. Now, one might wonder how such a phenomenon could be possible. After all, our own Milky Way, a spiral galaxy, also boasts a similar bar-like structure. Researchers hypothesize that the Milky Way's bar rotates cylindrically, channeling gas towards the center of the galaxy, triggering bursts of star formation. Previously, astronomers believed that this particular galactic feature marked the culmination of a galaxy's developmental phase, typically found in older galaxies, possibly those existing midway through the universe's evolutionary timeline. However, the insights garnered from the Hubble Space Telescope's historical observations of galaxy morphologies are evolving our understanding of the early universe. Contrary to previous assumptions, the recent findings from the Webb telescope data suggest that barred spirals may not have been confined to more recent periods in the universe's history. The discovery of the spiral galaxy Sears 2112 unveils the existence of galaxies resembling our own Milky Way, a staggering 12 billion years ago, at a time when the universe was a mere 15% of its current age. Sears 2112 was observed at a redshift of 3, when the universe was 2,100 million years old. Essentially, this implies that the light from this galaxy traveled for nearly 12 billion years to reach the James Webb Space Telescope, offering a glimpse into a distant era of cosmic evolution. This discovery is truly astonishing since it challenges conventional wisdom. Galactic bars, believed to have emerged around 4 billion years after the universe's birth, were not expected to be present in the early universe, according to the standard model of cosmology. Even theoretical predictions from cosmological simulations struggle to recreate such systems during those early epochs. This begs the question: what is causing this unexpected phenomenon? A scientist involved in the discovery remarked that we must now delve deeper to identify the missing key physical component in our models. Now, if you thought this was mind-boggling, consider that scientists estimate a staggering 85% of all matter in the universe to be dark matter, an enigmatic substance that eludes direct observations because it does not interact with light in any way. Dark matter is believed to have significantly influenced the evolution of galaxies and the formation of stars as early as 380,000 years after the Big Bang. However, the recent findings from this discovery paint a different picture of galaxy evolution, at least in the case of Sears 2112. When the universe was approximately 2 billion years old, it appears that ordinary matter, or baryons, the very substance of which you, I, and everything we perceive are made, dominated the evolution of this galaxy, contrary to the prevalent notion that dark matter plays a more substantial role, despite its abundance. These revelations are groundbreaking, and it's safe to say that the James Webb Space Telescope continues to deliver unexpected and transformative insights. We are living in an era of profound change in cosmology, where the universe's secrets are becoming increasingly accessible. What are your thoughts on these recent discoveries in cosmology, where the James Webb Space Telescope is challenging our understanding of the early universe, galaxy formation, and the role of dark matter? How do you think these findings will impact our knowledge of the cosmos in the coming years? Feel free to express your thoughts and viewpoints, and be sure to join the Revel Discovery community by hitting that subscribe button to stay up to date with lunar revelations and the forthcoming frontier of space exploration. Remember, as we venture into the universe, the sky is not the limit, it's just the beginning. Keep looking up.